This video is going to look at integration with partial fraction decomposition. So we talked about in 5.10.1, we talked about how if you do long division, you might get your function to look nice and be able to integrate with natural log. This is another way to get your function to look nice. So if the denominator is a higher power than the numerator, and you can factor the denominator, we can use partial fraction decomposition to get our integral into a form that is nice to work with. So recall that partial fraction decomposition allows a quotient to be rewritten as the sum of simpler fractions. So that's the whole goal here, is that we're trying to rewrite a complicated fraction as simpler fractions that we can hopefully integrate. And the best way to look at this is just to see it in practice. We're going to jump into an example here. And so this example is the integral of 3x over x squared plus 2x minus 8. So first of all, I can't use long division because the denominator is a higher power than the numerator. And that's okay because we don't want to do it. The second thing we'll check in a fraction like this is, does the denominator factor? And in fact, it does. We get x plus 4 times x minus 2. And so that's nice because those are linear and they're non-repeating, so we know we can use partial fraction decomposition. So let's decompose this into an integral that's easier to work with. So we're going to start by saying that 3x over x squared plus 2x minus 8 is equal to some unknown a over x plus 4 plus some unknown b over x minus 2. So again, that's just because the properties of algebra say that if the denominator of this fraction can be factored, there has to be some a and has to be some b that makes this hold true. So now our goal is to find what those a and b are. So if we find the common denominator, that's going to be a times x minus 2 plus b times x minus 4 all over x plus 4 times x minus 2. Now we know that this x plus 4x minus 2 was factored from the denominator on the left side, so therefore those are equal and they can be canceled out. And that means we get 3x equals a over x plus 4 plus b over x minus 2. And now we've got, or sorry, those denominators shouldn't be there because we canceled all that out. It should just be, if we write that properly, a times x minus 2 plus b times x minus 4. And now it's just a matter of finding out what a and b are. So we could distribute, set up a system of equations, solve it, or we can use our clever trick of knowing that if I choose x to equal 2, well then that's going to give me the expression 3 times 2 equals a times 0 plus b times 2 minus 4, negative 2. And then the a will go away. And that leaves us with 6 divided by negative 2. So b is equal to negative 3. Just circle that for later. And then if I pick x is equal to 4, it should be a negative 4. That will give me 3 times negative 4 is equal to a times 4 minus 2. Sorry, this is a complete mess. Let me restart that and double check everything. Okay, so it's x plus 4, which means we want to pick negative 4 to get rid of this b term. So if it's negative 4, we get 3 times negative 4 equals a times negative 4 minus 2, so that will be negative 6, plus b times 0, and that will give us an a is equal to 2. So now we've got our a and b, so that means this integral is also equal to the integral of 2 over x plus 4 plus negative 3 over x minus 2 dx. So all that we've done so far is just partial fraction decomposition to rewrite our function right here as a sum of simpler functions. Then we can break that up. 2 over x plus 4 dx plus the integral of negative 3 over x minus 2 dx. And then because these are nice, you can use u substitution. Go back and check the first video from this section if you're uncomfortable with that. But we end up with 2 ln x plus 4 minus 3 ln x minus 2 plus c. And that is our result. If you have any questions, let me know. But otherwise, that's how we integrate with partial fraction decomposition. We just decompose it, and then it ends up in a nice, for linear, non-repeating fractions, factors, it ends up in a nice, easy to integrate form. It will always work out to be something that integrates nice and easily with u substitution to get ln of whatever the denominator is.